Look up at the night sky for a moment. Every tiny point of light you see is a sun, and around many of those suns may be worlds we've never imagined. For thousands of years, human beings have stared into that vast darkness and asked the same question: how far can we go? We crossed oceans once thought impossible to navigate. We climbed mountains that seemed unreachable. We stepped onto the moon, turning a dream into a footprint. But what happens when our next destination is not another continent, not another planet, but the stars themselves? Imagine boarding a spacecraft capable of traveling farther than any human has ever gone. As Earth shrinks into a pale blue dot behind you, a new question begins to emerge. Could you reach another star before your life ends? Could you cross the Milky Way? Could you travel to another galaxy? Or does the universe have limits that no amount of courage, intelligence, or technology can overcome? The answers are far more surprising than most people realize. They involve enormous distances that stretch the imagination, strange effects where time itself slows down, and laws of nature that seem to place boundaries on even our wildest dreams. Yet hidden within these challenges is one of the most extraordinary stories science has ever told. A story about what it truly means to be human in a universe of almost unimaginable size. Today, we are going to embark on a journey across space and time. We will explore the incredible scale of the cosmos, the ultimate speed limits of nature, the mysteries of relativity, and the technologies that may one day carry humanity farther than ever before. Along the way, you may discover that the greatest obstacle to exploring the universe is not distance itself, but the way we think about distance, time, and our place among the stars. So stay with me until the very end, because the farther we travel into this question, the more astonishing the answer becomes. When we think about traveling across the universe, our imagination often moves faster than reality. Science fiction has taught us to picture enormous starships crossing galaxies in days or weeks, but the real universe operates according to rules that are far more fascinating and far more challenging. To understand how far humans could really travel in a single lifetime, we first need to understand the scale of the cosmos itself. The Earth seems enormous when viewed from the ground, yet it is only a tiny world orbiting an average star. The distance from Earth to the Moon is about 384,000 kilometers, which already feels unimaginably large. Light, traveling at nearly 300,000 kilometers per second, reaches the Moon in just over a second. The Sun is much farther away, about 150 million kilometers, and sunlight takes approximately 8 minutes to reach us. These distances are impressive, but they are merely the first steps into the cosmic ocean. The nearest star beyond our Sun, Proxima Centauri, is over 4 light years away. A light year is the distance light travels in 1 year, nearly 10 trillion kilometers. Beyond that lie thousands of stars, billions of stars in our galaxy, and billions of galaxies scattered throughout the observable universe. The scale is so vast that ordinary human intuition becomes almost useless. Numbers that seem enormous on Earth become insignificant when discussing the cosmos. Once we appreciate these distances, we encounter another fundamental reality. Nature has imposed a speed limit. According to modern physics, nothing with mass can reach or exceed the speed of light. This is not merely a technological limitation, it appears to be woven into the structure of space and time itself. As an object accelerates closer to the speed of light, its energy requirements increase dramatically. The closer it gets, the more difficult further acceleration becomes. Reaching light speed would require an infinite amount of energy, which means it remains unattainable for any object with mass. This universal speed limit creates a profound challenge for space exploration. No matter how advanced our technology becomes, we must confront the possibility that some destinations may always remain beyond practical reach. the conflict between human lifespans and cosmic distances is one of the most intriguing aspects of space travel. A typical human lifetime may span 70 to 100 years. Current spacecraft travel at only a tiny fraction of light speed. If we were to board one of today's fastest probes and head toward the nearest star, the journey would take tens of thousands of years. Entire civilizations could rise and fall before the spacecraft arrived. Even reaching destinations within our own galaxy would require timescales far beyond human experience. This means that under present technological conditions, interstellar travel remains effectively impossible within a single lifetime. The stars are not simply far away, they are separated by distances that challenge the very meaning of travel as humans understand it. Yet physics introduces a remarkable twist through the theory of relativity. Time itself is not absolute. It can stretch and contract depending on motion and gravity. When an object moves at speeds approaching the speed of light, time passes more slowly for those aboard compared with observers who remain behind. This effect, known as time dilation, has been experimentally verified countless times. Imagine a spacecraft capable of traveling at 99% of light speed. For people on Earth, the journey to a distant star might take many years. For the astronauts aboard, however, the passage of time would be significantly reduced. They could potentially travel to destinations dozens of light years away, while aging only a few years themselves. In a sense, relativity allows travelers to leap into the future. They could return to Earth and discover that decades, centuries, or even millennia had passed, while only a small portion of their own lives had elapsed. This extraordinary consequence of physics means that the limits of human travel depend not only on distance, but also on the strange relationship between space and time. To make such journeys possible, humanity would need propulsion systems far beyond anything currently available. Chemical rockets have served us well for reaching orbit and exploring nearby planets, but they are far too slow for serious interstellar travel. Scientists have proposed a variety of advanced propulsion concepts. Fusion engines would harness the same process that powers stars, releasing immense amounts of energy from atomic nuclei. Antimatter propulsion could be even more powerful, converting matter directly into energy with extraordinary efficiency. Another fascinating concept involves laser sails, in which giant lasers stationed near Earth push lightweight spacecraft to a significant fraction of light speed. These ideas remain largely theoretical or experimental, but they demonstrate that future technologies could dramatically expand humanity's reach. The challenge is not simply building faster engines, it is carrying enough energy, protecting passengers from radiation, and maintaining life support over journeys lasting years or decades. As our ambitions grow, we naturally begin asking whether humanity could someday leave the Milky Way itself. At first glance, the answer appears discouraging. The nearest major galaxy, Andromeda, lies more than 2 million light-years away. Even traveling close to light speed, such a journey would present extraordinary difficulties. Moreover, the universe itself is expanding. Distant galaxies are moving away from us due to the expansion of space. Some regions are receding so rapidly that light emitted from them today may never reach us. This creates a cosmic horizon beyond which direct exploration may be forever impossible. The universe is not merely large, it is dynamic, constantly changing, and in some respects placing certain destinations permanently out of reach. These limitations reveal something profound about humanity's place in the cosmos. We often imagine exploration as a process without boundaries, a continuous expansion into ever more distant frontiers. Yet the laws of physics suggest that boundaries may exist. Some are technological and may eventually be overcome. Others, appear to be fundamental features of reality itself. Understanding these limits does not diminish the wonder of exploration. On the contrary, it makes the challenge even more meaningful. Every kilometer traveled beyond Earth represents a triumph over immense obstacles imposed by nature. The future of space travel may involve solutions that seem strange today. Generation ships could carry multiple generations of humans who live and die during voyages lasting centuries. Suspended animation might allow travelers to sleep through long journeys. Self-replicating robotic explorers could spread across the galaxy before human settlers arrive. Advances in artificial intelligence, biotechnology, and energy production may transform what is possible. Concepts that currently exist only in equations and thought experiments could become practical realities for future civilizations. The question of how far humans could travel in a single lifetime ultimately forces us to think not only about technology, but also about time, physics, and the nature of existence itself. It reminds us that the universe is far larger than our everyday experiences suggest. It challenges our assumptions about distance and possibility. It reveals a cosmos that is both inviting and resistant, filled with destinations that inspire wonder while demanding extraordinary ingenuity. Every star in the night sky becomes a reminder of both our limitations and our potential, standing as a distant beacon that invites us to keep asking questions, pushing boundaries, and exploring the deepest mysteries of reality. As we reach the end of this journey, we find ourselves facing a remarkable truth. The universe is far larger, stranger, and more magnificent than our minds naturally imagine. The distances between the stars are so vast that they challenge our understanding of travel itself, and yet the human spirit has never been defined by what is easy. Every great achievement in history began with a question that seemed impossible to answer, and a dream that seemed impossible to achieve. Perhaps we will never cross the entire universe in a single lifetime. Perhaps some corners of the cosmos will always remain beyond our reach, but the story of humanity has never been about accepting limits without exploring them. It has been about pushing farther, learning more, and turning today's impossibilities into tomorrow's realities. The same curiosity that carried our ancestors across unknown oceans now drives us toward the stars. The most extraordinary thing is that the universe does not merely challenge us, it invites us. Every distant star, every mysterious galaxy, and every unanswered question is an invitation to explore, to discover, and to expand the boundaries of human knowledge. Whether humanity ultimately reaches nearby stars or distant galaxies, the journey itself will reveal some of the greatest truths about who we are and what we are capable of becoming. So the next time you look up at the night sky, remember that you are not just looking at distant lights. You are looking at destinations. You are looking at mysteries waiting to be solved. And you are looking at a future that is still being written by curious minds brave enough to ask, what lies beyond? Thank you all for joining me on this incredible voyage across space and time. I hope this exploration has inspired you to see the universe with new wonder and to never stop asking questions. May your curiosity remain limitless, your imagination remain fearless, and your passion for discovery continue to guide you toward new horizons. Good luck on your own journey of learning and exploration, and thank you for watching.